So our first thing before we start with our notes, we got a little brain teaser. So if n is a number, using mathematical symbols, how could you write the number before n and how could you write the number after n? What I mean by mathematical symbols, add, subtract, multiply, divide, numbers are allowed. If we don't know what the number is, if it's just n, how could you get any number before it or any number after it?
Who said it?
Does anyone know the previous number, how we can write it?
Oh, just like 10 men. Like, it's just.
So let's say n is 4. What would the previous number be?
4. Oh, 3.
Previous 3. So if n was 15, what's the previous number? So what could I do to that? Subtract n or n minus 1. I heard someone say n minus 1. I've heard it from a few tables. What would the next term be?
N plus 1.
N plus 1. So why this is important? Today we are doing sequences. Sequences are lists of numbers. When we have lists of numbers, the hardest part, I think, for most of y'all today is going to be the struggle of understanding the new formatting. We use previous numbers and the numbers after. We refer to these two types of numbers while using sequences. We just write it a little bit different, or write it in a form you have not seen before. It's written as a of n minus 1. That just means previous term, the term before. For the next number, that would be a of n plus 1. The a is the name of the sequence. So a could also be like C, P, anything. The part that matters is the subscript, that small numbers. The n minus 1 means the previous term, and plus 1 means the next term. We could also possibly see it with function notation. So if you see f of n minus 1 or f of n plus 1, that is meaning previous term or the next term. So for sequences, we have two types of sequences we do this year. One is one is arithmetic and one is geometric. Today we are only focusing on the arithmetic time. Arithmetic sequences, anyone can guess of what operations are used in an arithmetic sequence? Adding and subtracting, if anyone could read ahead. Adding and subtracting is the operations we use in arithmetic sequences. We add or subtract a number to get to the next number in the sequence. Whatever that number is that we add or subtract is called our common difference. When you see those formulas or you use those formulas, anytime you see that letter D, that's denoting, that's indicating the common difference. So we're jumping around kind of today. A lot of the printed stuff, like you can go back and read those examples all the way through if you need to, but I'm going to skip over them for all day today. Starting with this first part, just continuing the sequence. You see a pattern, hopefully keep the pattern going. So it's 3, 5, 7, 9, 11, 13. Okay, 13, 15, 17. How did you get those? You know that it's adding 2. That means your common difference is adding 2 or 2. I think y'all can do the rest, right? Okay. So I don't think you're going to struggle with, I give you numbers, you figure out the pattern and keep going. So, because that's all we're doing. It's just a sequence, like what's the pattern? We're going to write them as equations. We're going to make them into tables. Making them into tables isn't hard either. If we have this example here, a sequence. A sequence is just a list of numbers. 4 would be the first number in the sequence. That 6 would be the second, third, fourth, fifth. Right? Where they're located in the sequence, turn it into a table. That's all it is. So if we go to the next page, we have a sequence of 2, 4, 6, 8, 10. 2, 2 is the first number in the sequence, so 1, 2, 3, 4, 6, 4, 8, and 5. Next. Are we okay with turning that into a table? What's the common difference? So what's being added or subtracted every time? It's adding 2. And then those blanks, we're going to write it out in words. We're going to describe the sequence in words. If you are describing a sequence, what's the most important part that I have to tell you in the beginning? Okay, the common difference is important, but if I want you to write a sequence and I want it to match mine, if I just say add 2, is yours going to match mine? You have to tell me the first number first, all right? I can start with anything and add 2 to it. So we have to say what the first number is and then our common difference part. So start with 2, right? Our sequence start with 2. Then add 2 to the, we're going to use some math terms, previous number, or previous term. We're going to go below and do number 3. So make it into a table first. First term is 10, second term is 8, third term is 6, fourth is 4, and then 5 is 2. What's it going by each time? It's subtracting 2 every time. So we're going to write it out in words exactly like what we did before, but now plug in the different numbers. So start with 10. Then subtract 2 from the previous term. Okay. Let's try another one. First part, make it into a table. 1, 2, 3, 4, 5. So the first term is 3, second term 6, third term is 9, fourth term is 12, and then fifth term is 15. What's the common difference? Adding 3. Okay. Now we're going to do something a little different. Instead of writing it out in words, in those blanks, we're going to turn the words into math. The math version of it. It's still going to say the same thing. Start with 2. So in this part, we want it to say start with 3, but we need to write it in the math form.
3 plus 3.
No.
Well done.
That a sub 1, that means our first term. Our first term is 3.
Why is it A?
Yeah.
Like, why?
A is just the name of the sequence. It could be B, it could be C. The part that you have to pay attention to when it's a sequence is the subscript, so the small thing below. Okay.
Oh, there's a word. There's a comment.
Then for the next part, so to get every other term means to get anything else in the sequence, we were saying add 2 to the previous term, subtract 2 from the previous term. We talked about previous term. Previous term, that's what we did here. We can denote previous term as this part. So a of n minus 1, that just means previous term. And what do we need to do to it? What's our common difference for that problem?
Plus 3.
Plus 3. So we just wrote the exact same thing that we were writing earlier, just in math form. The first part in blue, that says the first term is 3, This next part is saying previous term, add 3 to it.
Wait, why is it a of n minus 1? Like, is that just like the first one?
Here?
I like the minus 1 part of it.
Did you get it when we did it here?
No.
Okay, so if I have the number 5, how would I get the previous term? Subtract, go back 1, which is subtracting 1. So anytime you see that n minus 1 as a subscript, is just saying going back a term. So let's try the next one. As we go through it, the more y'all see it and practice it, the easier you'll get with the formats. So on the next one, huh?
Third line.
It's blank. We can leave it blank. Okay. Are we okay with making the table? Okay, what's it going by? It's subtracting 1. So every time, we always said what the first term is. Start with whatever the number is. So start with 3. Then to get everything else, previous term is a of n minus 1. And what do we need to do to it every time?
Minus one.
Subtract 1.
Minus one.
The n minus 1 here is a subscript, so it's not like subtracting. Okay. Let's keep going. We're going to skip to the next page. Yes. I'm telling you, this today is just, by the end of class, I think you'll get the format better. It's just a confusing format. Yes, I had to learn this in algebra as well when I was in so, we're going to skip to the next page. And we're going to do this section first, this middle section first. So in this middle section, instead of having to write the formula, we're now trying to match the formula with the sequence. The part from the formula that matters. The first term, so if you look at this first group, what's the first term?
2.
2. And then what's it going by each time? It's adding 2. So look at these answer choices. Which one is saying the first term is 2 and then it's adding 2 each time? D is correct. Okay, do the rest of them. Alright, so back at the top part now. Now you're given a formula, and from the formula, write the sequence. From that formula, what is it saying the first number is going to be? It says the first number is 7. And then what is it saying to do to get to the rest of the numbers?
Plus 4.
Add 4. So the next number would be 11, then 15, 19, 23. The directions say to go to the 5th term. Let's practice. So if we look at the next example, what's our starting number? 12. And then what do you do each time?
Minus 3.
Subtracting 3. So that would be 9, 6, 3, 0. Okay. So the type of sequences we just did. Arithmetic, but there's 2 types of arithmetic sequences. The one we just did was recursive. And let's think about the word recursive. Recursive kind of sounds like cursive, which is a handwriting. If you write in cursive, how do you have to write in cursive? Like, what do you have to do?
Like
Connect the letters. It's all connected. So recursive, if I asked you to find the 45th term of this sequence, what would you have to do? Keep going. Because recursive means we are connecting it all. So if you have to pick the 45th term, that means you have to know all the terms before you get to it.
Wait, could it even multiply 4 times 4?
No.
Ooh, okay. I will tell you the answer is,
Incorrect.
well, no. You can't just multiply by 45.
4 times 45.
No, like do 4 times 45 and then just add it on to the last number you have.
That'll work.
No.
So how much?
There is a way to do the multiplication. So we have the two forms, recursive, and then this next form is explicit. The explicit does include multiplication because these are all including repeated addition. What is repeated addition? What operation is that?
Multiplication.
Multiplication. That's why we have the second form. Because that way, if I do ask you to get the 45th term of a sequence, you can just plug the number in. Because this form, you can't plug things in and just get an answer. It's just telling you how to make a table. So, let's go to the next page. The top of the next page has the formula for explicit. It involves multiplication. I'm going to make a tiny change. What did I just do? I moved it because normally y'all are used to distributing from the front of parentheses, not the back of parentheses. It doesn't make a difference that you can distribute from both places, but I think for y'all, I just switch it. So going through. A with that subscript of 1, A sub 1. We know what that means. What does that mean? That's our first term. Well, how come we would need to include a starting term for our formula?
So you know where to start.
Yeah, you know where you start. All the sequences are starting at different places. Because if I just multiply the common difference times our number, well, that would be saying it starts at 0, which is not what happens for every sequence. They all start in different places. So that has to be included. We're multiplying the common difference. So if I were finding the 44th term, I would actually be multiplying the common difference times 42, not 43, for this formula. Anyone know why?
Because it's minus 1.
Where do sequences start? Sequences start at 1. So if I'm finding the 43rd term of something, how many spots are there between 1 and 43? There's actually 42. That's why we have that n minus 1 in there. If you do not understand that part, that's okay. You're going to get the formula and you're going to be fine.
Please, this is like
We're going to go through 2 examples. Once we get through 2 examples, I think most people will be on board, so we'll do another example just to make sure. So we're going to do some new stuff and some old stuff. First thing, we have a list. We can turn it into a table. This is the part. Don't phase out. Stay with us the whole time.
too late.
Come back. Okay. The list into a table. We have done that already. That should feel okay. The other thing should be okay. The first term. What is the first term of that sequence?
4.
Okay. And what is the common difference? Adding 4. You see there's going to be a spot for the 50th term? You have 2 options to get to that 50th term. You make a table and keep going to 50, or you learn this other way to do it, or we can just plug 50 in for a rule and get an answer. Okay, you can do that. I'm not wasting my time. In our explicit form, the first part we write, what was the first term?
4.
Okay. Hold on. The second part, remember I move that common difference to be in front of the parentheses. So what's the common difference in that problem?
4 plus.
So plus 4, and then n minus 1 is part of that formula. To go from the formula to the rule, distribute, simplify. Distribute that 4 that's out there. Simplify, meaning combine like terms. So what will that become? 4n. So our rule, to get any term in that sequence, multiply 4 by whatever the term we need. So if we're trying to get the 50th term, 4 times 50.
Wait, but why would it work with the other one then?
Yeah, wouldn't it?
Same thing.
Say again?
You said it wouldn't work with the other one if I just multiplied it and then did that. But
This one is a coincidence because the first term and the common difference are the same number. It won't work on the next one. You'll see. Okay.
So I
That coincidence is only because the first term and the common difference are the same numbers, and you'll see why. You'll see. Just trust me.
They still have to do that.
I can't find my water.
Making the table, so 1, 5, 2, 8, 3, 11, 4, 14, and then 5, 7. Things we can also fill in. We know what's the first term of that sequence.
What? Yep.
And the common difference is adding 3. So for the formula, that first term is 5. We're moving the common difference, so it's in the common parentheses, not behind it. So plus 3, and then n minus 1. That is the formula. It will be a lot easier if we distribute and combine it for the rule part. So if we distribute the 3, that's what we get, and then combine terms. So
It's not 5.
3n, 5 minus 3 is 4. Okay.
8 plus 3.
So then using that rule for the 50th term, 3 times 50 plus 2, 152. So that trick of just trying to multiply. Okay. I skipped something on both examples. What did I skip?
Graph.
Okay, we're gonna go back and graph.
Yeah.
On the first one, we can't get all of the points on there, which is fine. Get what we can.
Oh. We can get to.
We can kind of get 311. It's one space up. Oh, I did the second. 311. Does anyone remember how to write equations for lines?
Nope.
Like the y equals mx plus b stuff? So you remember what the y or the m stands for? Can you get the slope of this between those 2 points? What's the slope of that? Okay, so rise over run, so that's going up 4 and over 1. So that makes it 4x. What does b stand for? Okay, we don't see it, but could you follow the pattern in the other direction and figure out what it is?
0.
Okay,
So.
so 4x plus 0. Let's do the other one. What's the slope of that second one?
3.
Up 3 over 1, so 3x. And then if we put the y-intercept on there, it would be 2. So who figured it out? Look at the blue that's on the board. All of the blue that's on the board.
Oh my God. Was it X?
Just trade the X.
This
That's good. Whoa.
The only reason that we can't just do slope-intercept form for sequences is because that y-intercept is saying the zero term. Do we have a zero place if you're listing things? No, it goes one, it's all positive numbers, 1, 2, whatever the sequence is. But it really is just slope-intercept form. It's the exact same thing. So we're going to practice slope-intercept form on Thursday. So if you get the hang of that, by all means, just apply it to our sequences. Or you can just use it to double check your sequence. Like, did you get your sequence right? If you made it a graph, would it match your slope-intercept form you made from it? Now that we've done that, let's do one more example. So this one more example. Here's our first, second, third, fourth, fifth. What's the first term of the sequence? 0. And what is the common difference?
4 plus 4.
It's adding 4. So then, first term is 0 plus 4 times n minus 1. Because remember that common difference we write in front of parentheses? And now distributing. Do I need to include the plus 0? Okay. So then 4n minus 4 is our official rule. If you have a rule, you can now plug numbers in to find their position or find the number in the sequence. So to find the 50th term, that's 4 times 50 minus 4. 196. Good. And now if we were graphing it, we have 1, 0, 2, 4, 3, 8, 4, 12 doesn't fit. What's the slope of that line? 4. Okay.
4.
So 4x and what minus 4. What part of your sequence is always going to be your slope? What part of your sequence is always going to be the slope of that line? So multiplying with n. Yes. See the common difference. If you look back at the other two that we've done, our common difference ends up being the number that is multiplying with the variable. Okay. The rest of those, so those 3,